Okay, here we go. So today we want to be able to rationalize the denominator and multiply and divide fractions. We're going to start right here. And I just want to make sure we review the perfect squares. I've got 1 through 8 listed out. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64. After that, 9 squared is what? 10 squared? 11 squared? 121, 12 squared? 13 squared? 14 squared? 196, 15 squared, 225, and 16 squared, 256. Hopefully those are ones that you remember. Just want a quick review what we did a couple days ago. 2 roots of 7 minus 5 roots of 7. Can you do that? Yeah, and what is 2 roots of 7 minus 5 roots of 7? Can you do 3 roots of 18 plus 4 roots of 50? Technically you can, but first you must. Yeah, so we have 3 roots of 9 roots of 2 plus 4 roots of 25 roots of 2. Good. Square root of 9 is times 3 is, yeah, so 9 roots of 2 as Campbell said. Yep, square root of 25 is 5, times 4 is 20 roots of 2. I get 29 roots of 2. Great. So, in order for a radical to be simplified, it must have all perfect squares or cubes or whatever you're working with, okay? Squares, cubes, fourths, things like that removed. So that's one thing. We've talked about simplifying that way. But here's another rule that comes up in math. And it's hard to give you an answer as to why we say this in math. I actually think it's kind of a silly rule. And no radical in the denominator. That kind of bothers me. Like, why? Like, usually when we talk about things in math, I want to say, why is that the case? And other than our answers matching up with the textbook, I don't really know why we don't like to have a radical in the denominator. I'm going to start to research that. I really don't like it. But it is what it is. And it's something we have to prepare for the AccuPlacer. So here we go. Square root of 4/9. One nice thing about radicals is you can take the square root of the top and the square root of the bottom. Okay? So just like you can divide multiplication up with radicals, you can divide division up as well. So square root of 4/9 becomes 2/3. Now I'm not going to write it every time as the square root of top over the square root of bottom. You can just think about it. The next one, square root of 25 over 49, will be 5 over 7. And the square root of 1 over 256 is 1 over 16. Hey, we're flying. But example 4, you start to run into a roadblock, right? So on the top, you just leave the square root of 6. On the bottom, you write 5. And we would say that that's simplified. That's okay. We can leave it as square root of 6 over 5. You don't have a denominator that's radical. Next one, we say negative square root of 2 over 7. And we say that that's fine. You can put the negative with the top or the bottom or out front, just as long as you have one negative. And next one, we got square root of 7 over 10. But then you flip it over, you look at the backside. Here we got square root of 2 over square root of 3. Now, that's a problem because you can't have square root in denominator. So what do? By? Very good. I multiply by the root of 3 over the root of 3. The root of 3 over the root of 3. Which, what is the value of the root of 3 over the root of 3? 1. You can multiply something by 1 and not change its value. So in the numerator, we get the square root of 6. What do you get in the denominator? You get 3. Square root of 9, which is 3. So now this is simplified because the denominator does not have a radical. Oh boy. Cold call me in the middle of the day. That's what you're going to get. Here we go. Square root of 5 over square root of 2. What do I do? Square root of 2. What do I get at the top? Square root of 10 over, which is 2. Now, example 9, that one requires just a little bit more work. I multiply the top by the square root of 6 and the bottom by the square root of 6. In the top, I get the square root of 18 over 6. Am I done? What do I have to do? Square root of 18 reduces to square root of 9 times square root of 2 over 6. Or 3 roots of 2 over 6. Am I done? 3 over 6 is, so root of 2 over 2. Or we'll do 3 more. And trust me, the third one, I don't think most people see how this is going to work out. And we'll save you some time. Multiply top and bottom here by the root of 3. 6 roots of 30 over 3. Can I simplify that? Yep, 2 roots of 30. Top and bottom by the root of 2. 8 roots of 14 over 2, so 4 roots of 14. Or number 12, does that bother anybody else that you would like multiply the top and bottom by the root of 35? Like, I don't really, okay. What I don't like is trying to deal with the square root of 350. So I'm going to show you a way around this. This is a really, really good option for working with square roots. -4, root of 5, root of 2. And I know some of you are like, why would I raise the root of 5 times the root of 2? Because you can't take the square root of 5 or 2. But watch what you can do in the denominator. Square root of 5 times square root of 7. Well, what happens? Yeah, if I see that something divides out, go ahead and divide it out. Get out of here, 5. Thank you, Colby. Now we have the -4 roots of 2 over the root of 7. Well, that's a lot easier to deal with. Now instead of dealing with the square root of 350, I'm just going to deal with the square root of 14. So square root of 7. Whoop. Or square root of 7. So I get -4 roots of 14 over 7. And that's it. So notice how if you remove the square root, that's a good deal. So what you're going to do is you take the next sheet and rip it off. That's your assignment. You've got half an hour. Half an hour. And as you can see, we did 12 problems in about 10 minutes. Should be able to work through pretty quickly.